Welcome to Physics Prep. This is a question from TATA-GS 2019 in which it tells us that there are three wires and we need to find the point where the magnetic field due to the wire vanishes. So first, let's take a single wire. Then, if there is a current I flowing through the wire, there is also a magnetic field around it. Now, if we add a second wire to the mix, now here is a second wire and we see that the fields interact right here. The magnetic field due to the second wire comes this way and due to the first wire comes this way, which actually looks as if they are cancelling each other. So at this point it has to be 0, which would be d by 2. Our answer would simply be d by 2. However, when we add up a third wire, what happens is that the magnetic field due to the third wire mixes up with the other two. So this one changes our value from 0 to something that is not equal to 0 at d by 2. However, at some point, the magnetic field does equal 0 because there is perfect cancellation and we need to find this point. Now that we have a qualitative understanding, we can use Ampere's law, which tells us that the magnetic field around the wire is B equals mu naught I divided by 2 pi r. The r here is quite interesting. It tells us the distance from the main wire to the point where it is 0. Let's say the point is here. Then let's write this as r. That is r from the middle wire. The magnetic field is 0, and since the magnetic field adds up vectorially, we have to consider the directions. Magnetic field due to 1 we can see going in the upward direction, due to 2 goes in the downward direction, and due to 3 again we can see that due to 3 goes this way, which means at this point it goes in the downward direction. Now, which means B1 plus B2 plus B3 must be equals to 0. With the distances, we have been told in the question that the distance between two wires, that is this distance is actually d. Then the distance from this wire up to here would be, since we already have r on one side, the other side it should be d minus r, and from the third wire, the distance up to here should be d plus r. So let me write that here, d plus r. Mu naught I divided by 2 pi d minus r minus, because it's in the opposite direction, mu naught I, all the three currents are the same, minus mu naught I divided by 2 pi d plus r, and this is equals to 0. The common terms can be taken out and be equated to 0, which leaves us with, this implies 1 by d minus r minus 1 by d plus r equals 1 by r, giving us d minus r minus d plus r divided by d squared minus r squared equals 1 by r, which gives us d squared minus r squared equals twice r squared. This implies r equals d divided by root 3, and this is our solution.